Hi, in this video lecture, we will learn the difference between string copy and memcpy functions. A string copy is a commonly used function. It is used to copy strings. And we can see out here, the string copy basically takes two arguments. The first argument is a character pointer to a destination string. The second argument is a pointer to source. And for the source, we can see it's pointer to const, indicating that the source string will not be modified. And for destination, we don't have this pointer const, meaning destination will be modified. It also returns a pointer, which is same as the destination string. On the other hand, memcpy, it's a very similar to string copy. It is again used to copy a block. It takes three arguments: pointer to destination, pointer to source, and the third argument, which is the number of bytes to copy. Other major difference out here is string copy works with character pointers and memcpy basically works with void pointers. Void pointers are called as generic pointers, and memcpy can be applied on any data type. It can be applied on integers, characters, float, double, structures, anything. Let's try to write a small program to understand the difference between memcpy and string copy. Here, I've taken a simple program wherein the source string is an array of 10 characters. I've initialized that character by character here. The first three characters SIK. The fourth character is a null character here. And after that, we have the remaining part of the name ANDER, again ending with null character. I've taken two additional strings called as A and B. And in the next two statements, I'm using string copy and memcpy. And for memcpy, I'm passing three arguments. So let's try to run this program and visualize it and understand the functioning of it. Let's start the execution. The execution starts from the main, and line number 6 is going to create an array of 10 elements, and it's going to initialize it with the data, whatever we have set. You have SIK, then we have the null character, ANDER, again the null character. When I use the string copy, I'm passing A and the source. The question now is, will it copy all the 10 characters, or will it copy only up till the first null character? Let's observe here. Here you can just observe it start copying from the first character, then second character, then third character. And once it copies the first null character, it stops. It just stops. It is not bothered about the remaining portion. It just stops on encountering the first null character. Now let's look into memcpy. Now in memcpy, you can just observe it has copied all the 10 characters. Memcpy does not look out for null character and then, okay, it stop on reaching the null character. It just copies n number of bytes. It doesn't look into the data is null or a non-null value. But if we just try to execute this and then try to print A and try to print B, the output will remain the same, like SIK and SIK. The reason being, even in the second one, like the B, it will only print up till the first null character whenever you use %s. But you can just observe the remaining portion is also copied. Quite often, whenever you wanted to copy strings, we generally rely on string copy because we are least bothered about what is present after the null character. But memcpy is also used to copy non-strings like integers or structures. If you want to basically copy, we can also use memcpy. I hope this concept is clear with respect to working with character arrays. Now, I'll try to modify this program wherein instead of using a character array, I'll try to use an integer array. I'll just change it to an integer array, and then I'll just try to initialize it with some values here. I've initialized some values, and I'll change this also to integer array out here and integer array here. And I'll just try to reduce the number of elements to 5 here. And I'll just try to initialize it with 0. And whenever an array is partially initialized, remaining elements will be set to 0. I'm using a similar concept out here, string copy A comma source, memcpy B comma source. But remember here, the source is an array of 5 integers. And if each integer is 4 bytes, it will be 4 into 5. Or I can also say that size of int into the number of elements. The number of elements what I have it is 5. I'd like to copy this. And here, I cannot use printf with percentage yes to print the elements. I can just use a for loop to print 5 times. I'd like to print the elements of A. I would not like to have this new line character. I'll say A of I. And on the same lines, I'd like to also print the contents of the array B, which is an integer array. And in between these two, I'd like to just have a new line character. Let's try to run this particular program and visualize this. So first, the program execution starts from the main, and it's going to initialize the array with the values. The contents of A is 0, because whenever an array is partial strings, remaining element will be set to 0. The same way B is also set to 0. Now when I try to write string copy A comma source, and you can just observe the first element is copied, remaining elements are not copied. Now let's look into memcpy. You can just see every element is copied out here. Okay, why is it? Did we see 0 out here? When you look at these elements, we don't see 0 here, but you can just go to the byte level view out here. If you look into the byte level view, the 12, which are stored using 4 bytes here, the first byte on a little Indian machine, this was 12. It was stored in the first byte. Second byte is 0. It just copied the second byte and it stopped. Right? That's what basically happened. And let me just try to print the contents. And you can just observe the contents of A will be 12 followed by 0, 0, 0, 0. And the contents of B is 12, 23, 34, 45, and 56. To understand a little bit more about it, I'll try to modify this code in a way wherein this is a little bit larger value. I'll try to use hexadecimal. It'll be easier for us to understand. And here, if you want, you can basically have this 0x, FF, 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 or any values, like any junk values. You can basically have it for all. I'm just setting every byte to 1 here. Right? The same thing can also be applied out here. Now let me just try to execute this. So the first statement, source, here, it is sending up the values 1, 2, 3, 4, 5, 6, 7, 8, the first hexadecimal value. Second one, 23, whose hexadecimal value is 17. And the same way, other values are also set out here. We can just move around, see the values out here. And please do observe for this first one, neither the first byte is 0, nor the second byte, neither the third byte, and the fourth byte. The second element, you can just see if the first byte is non-zero, second byte is 0. Right? Now let's come back to executing the next statement, B and A initialization. And all the bits are set to 1 because of FF, and the values are -1. Now after that, when I use string copy, first it copies the first byte, then second, okay, it verifies it is null or not. No, then copies the second byte, third byte, fourth byte. Then it copies the fifth byte and also copies the sixth byte. After copying the sixth byte, since that is a null character, it's going to stop. So you can just observe this is completely copied. And here what you can just observe is this portion is copied. You can just see 1, 7, you can observe here. And the remaining information, you can, okay, second byte is 0, 0. But if you can just observe the remaining portion, it is FFF. Right? Okay. Now we can just try to print the values out here. Now before we could print, let's try to use memcpy. And memcpy is going to copy all the bytes irrespective of looking at where did we find the null. So it has copied all the elements. Now if I try to print the contents of A, first value is copied correctly. Second value, only 1 byte is copied. Now second byte is, again, yeah, second byte is also copied. The third and fourth byte is not copied. So whatever the previous value, the same thing is mentioned. Considering overall values, we got this particular thing. And then the remaining elements are not copied. Whereas memcpy can just observe everything is copied. And yes, even though I've initialized with 0x1, 2, 3, 4, 5, 6, 7, 8, But while printing, since I'm using percentage %d, so it is printing the decimal equivalent of that particular value. Here you can see the hexadecimal, here you can see the decimal. This decimal value is printed out here. Fine. So this is a major difference between memcpy and string copy. String copy basically copies and stops on copying the first null character. Memcpy copies every byte. String copy is generally used with strings because we are least bothered what is present after the first null character. Whereas memcpy, we don't want to stop on encountering the first null character. We would like to copy all the bytes. Fine. So memcpy can always be applied on any data type, whereas string copy is generally applied only for character data. I hope the concept is clear. Thank you.